You good boy. $97, $98, $99, $100. Nice. All right, now that we've had a good reminder about how to take care of our bodies while we're at home right now, it's time to take care of our mind by learning some more math. Our focus this week is going to be inverse trig functions. So what we've worked on so far is we've been given problems similar to this, where we have an angle of elevation or depression, and we are told what that angle is, and we use that angle along with one side measurement to find a missing length. We're going to use inverse trig functions now to find the missing angle measurement if we're given two of the lengths that we have. This is called an inverse because instead of like the sine function takes in the angle and gives out a ratio, we're going to use the inverse of the function to put in the ratio and get out the angle measurement. You can see some examples at the bottom of your screen where the sine function would take in an angle measurement of 30 degrees and give out a ratio of 1/2, where the inverse would take in the ratio of 1/2 and give out that 30-degree angle measurement. So this is just a way for us to work backwards. This works the same way with with cosine and tangent. Okay. Notice the symbols here. We have that -1 that denotes that we're working with an inverse. And it's important to take note that this is an inverse. This is not a reciprocal. So we're not working with cosecant, secant, cotangent. Those are simply reciprocals of the ratios. We're working with the inverse. We're putting in a ratio and getting out an angle. So here's a chart, okay, of our inverse functions. Now, we do have another name for them. They are sometimes called arcsine, arccosine, and arctangent. This textbook does not use that language, but that is something that you may encounter. What this textbook uses is simply what you see here in the chart. They use that -1, that inverse notation that we've learned about before. All right, so in order to find your inverse functions using your unit circle, what we'll do is we'll use our unit circle in an opposite way. So you might be asked, for example, what is the inverse cosine? And remember, we're going to get out an angle. We're going to put in a ratio of 1/2. Okay? So we would look at our unit circle, and we would look all the way around the unit circle. And I know cosine is an x value. So I'll be looking at my unit circle for an x value of 1/2, and I want to know what angle measurement gives that. Well, if you see the picture here at pi/3, I have an angle or a ratio of 1/2, that x value of 1/2, and also at 5 pi/3, I have the same thing. So there's going to be more than one answer when we're asked to use our unit circle to find these inverse relations. Now, even more than that, let me erase so we can see here. Not only do I have these two angle measurements I could get out, but don't forget, I could go around 2 pi or 360 degrees plus that little bit more. And I could have pi/3 plus 2 pi. Or I could spin around more than that. I could go around my unit circle. Let me get a different color so you can maybe see this a little bit better. I could spin around once, twice, and then land on that angle. And now I'm at pi/3 plus 2 pi and 2 pi. So 2 pi times 2, or 4 pi. So when we're working through these, we're going to denote that we have an infinite number of solutions by writing plus 2 pi n at the end of our angle measurements to show that I can use pi over 3, or I could spin around once and then add pi over 3, or I could spin around twice, and so on and so on. That n stands for how many times you spin around. You could spin around once, twice, 0 times, okay? So that's how we'll formulate our answers. So let's try a few of these. Let's start with the inverse cosine of the square root of 3 over 2. So we're going to look at our unit circle. I've got a cosine, so that's an x value, and I want to look at where are their x values, and notice this is a positive square root of 3 over 2. So take a moment, look at your unit circle. Where do you see that? Oh, yep, I see that too, pi over 6. And then I see it again, follow your way around, at 11 pi over 6. Remember, cosine is positive in the first quadrant and the fourth quadrant, so actually you only need to look at those two places. But remember, we could spin around, so we write plus 2 pi n at the end of our answers. All right, let's do the next one, tangent. Well, tangent is y divided by x. And what would have to be true about the y value and the x value for y divided by x to be equal to 1? You're right, they need to be the same. Not only would they need to be the same value, they'd have to have the same sign. So we're going to be looking for where both your x and your y value are the same thing and the same sign. So take a look around your unit circle, and you should find that at pi over 4. And then again at 5 pi over 4. 5 pi over 4, we see negative square root of 2 over 2, negative square root of 2 over 2. So remember, a negative divided by a negative is a positive. That's why that one works. And then we write our plus 2 pi n at the end. All right, last one of these. I'm going to switch colors and then show an arrow for my work. So I'm going to come up over here. Sine. We know that the sine are the y values. So we're going to look for where are their y values of negative square root of 2 over 2. That will happen in quadrants 3 and 4. So take a look. Where do you have that negative square root of 2 over 2? I see it at 5 pi over 4. And then I see it again at 7 pi over 4. Don't forget to add that 2 pi n at the end to say, well, you could also spin around and you could land there infinite number of times. Okay, notice I did all of my work in radians. It is not required, but it is encouraged, and every time you see these in your textbook, you will see the work done in radians, and it's good practice for us. We're good at knowing that we can go 0, 90, 180, 270, 360, okay? This is good practice for us to do this. But this is also limited in its application when we have infinite number of solutions. So, what we do to cope with that is we restrict the domain for all three of our trig ratios. And this is what actually gives it the status of being a function and not just a relation, because we've learned that functions have exactly one output for each domain value. Remember, the y's cannot repeat. So we can't have an infinite number of solutions. So we restrict our domain, so then we can talk about this as a function. So sine's domain is restricted to just these quadrants 1 and 4. Cosine is quadrants 1 and 2. And then tangent is the same as sine with 1 and 4. And what this allows us to do basically is just have one of each value. Because by having our sine, I'm going to draw a bigger circle here. Function limited here to positive 90 down to negative 90. What we have are positive y values and negative y values. So we can come up with one of each value that we see in our unit circle. Oops, I'm sorry, you can't really see that. Now cosine is restricted to these top two because cosine are x values, and same thing, we would have positive x values in that first quadrant and then negative x values here. One important thing to notice in these restricted domains is that sine is restricted from positive pi over 2 to negative pi over 2. So when you're given answers, if they are in this first quadrant here, you would have your positive numbers and then down here negative. So you're not going to be using numbers like 330. You would say, oh, 330 is 30 degrees down from the x-axis. I'm going to use negative 30. Cosine is the easiest one, honestly, because you're just going to go from 0 to 180, read what you see. And then tangent is the same as sine. Here's another chart with all of this information on it. Personally, I find those pictures with the circles on it easiest because I can just remember the image and I can go from there. So that's what I visualize in my head when I'm working through these. But here is all of the notation that goes with it. So let's try a few. Okay, we're going to evaluate each inverse trig function, and we're going to give our answer in radians and degrees, and we will have one answer that we will write in our 2 units. We know that we will have one answer because we are given our function with a capital letter. That's how your textbook denotes that we're working with our restricted domain. So let's go ahead, let's look at cosine. Remember, cosine is the x values. And when we're working with cosine in a restricted domain, we're only going to look in these top 2 quadrants. So at your unit circle, when you look there, you just have to look at that top half. So go ahead, take a look around your unit circle. Where do you see an x value of negative square root of 3 over 2? 5 pi over 6, that's where I see it as well. And then don't forget, you're asked to give your answer in both radians and degrees. So that is also equal to 150 degrees. And that's it, just the one answer, okay? Restricted domain gives one output. All right, let's go to sine. Sine is the y values. This time we're looking for a sine. Remember, sine is in the first and fourth quadrant. And we're looking for a y value of 3/2. So look at your unit circle. There is no y value of 3/2, is there? Okay, when you get something like this, where there is no y value that exists there, okay, we write undefined. This is undefined because 3/2 is equal to 1.5, and the highest and lowest that your unit circle reaches is 1. Because it's a unit circle. So it goes from +1 to -1. It does not stretch up to 1.5. It is undefined past that point of 1. Okay. I'd like you to pause the video in a moment, and what I would like you to do is go through some of these extra problems here for some extra practice. When we come back, we will look at the answer key.